All right. Well, Michael and Greg, thank you very much. Even though I'm no longer in Los Angeles, I live in Houston, Texas now. The LA.net meetup group holds a special place in my heart. You guys were part of my spiritual home in the Los Angeles.net ecosystem. And I always loved attending the code camps, the SoCal code camps that we would do every a few times a year. And boy, do I really hope we get back to a place where we can start doing those again. But that being said, the disruption to everyday life with COVID gives us the opportunity to go ahead and do things like virtual meetups like this. And so I'm really glad to have you all here to talk about a concept that I'm really passionate about and I think ultimately affects everyone in this room. And that's the coming open source sustainability crisis. So a little bit about me. My name is Stannard. I'm the CEO of a company called Petabridge. We've been around for just about 6 years now. I guess it'll be 6 years in January of 2021. And we are an open source business that is built around Akka.net, which is a distributed actor framework for .NET developers. And we get used by everything from banking systems to real multiplayer games to e-commerce to IoT. Even Greg's company uses us for some of their stuff. So we're kind of all over the place. And so as a result of the work that we've done with Petabridge over the years, we've started observing a number of sort of big ecosystem trends in open source as a movement. So what we're going to cover today is the first thing I'm going to touch on is sort of the current and past state of open source. Things are not as linear as they might appear to be in the sort of current moment of 2020. Open source has waned and has waxed over the years. And we're going to talk about that first. Next, we're going to talk about the real business risks of open source. Open source is not just some free lunch where developers you don't have to pay solve problems for you. That's not at all how it works. And it's definitely not going to keep working that way if that's what it looks like for you and your company right now. The problem is that there is a misalignment of incentives between consumers of open source and producers today. And if we don't come to a place where we can align those incentives, the ecosystem is going to take a turn for the worse. So let's talk a little bit about some of the good and bad solutions for aligning those incentives. And then I'll close tonight with a warning about what will happen if we don't address these problems. So open source is a movement that's kind of evolved and grown over time. This may come as a surprise to some of you, but open source is originally how software began. In the 1950s, and certainly prior to that, with the advent of sort of mainstream electronic computing, which was all done via mainframes back in the day, all software was in the public domain. And this is because the costs of software development relative to hardware development were trivial. The most expensive part of getting involved in computing wasn't the development of the software, it was being able to purchase and get time on a computer. So as a result, software was kind of an afterthought from a business point of view. It was really the hardware was where all the money was. This began to change in the 1960s as hardware became more powerful, more efficient. These were still big, bulky mainframes, mind you. So these are still big IBM-sized computers. But the costs of software development began to rise a lot to a point where it became very noticeable on the bottom line for companies like IBM. So they began to charge licensing fees for programs like their operating systems, their database software, and that type of thing. Now, back in the 1960s, though, when you bought a license to a piece of software, you usually received the source code sent to you as sort of a physical media. So if you needed to make modifications of the software yourself, you could still do that. That's pretty different than the proprietary software that we're used to in the 1990s and 2000s, where it's all kind of closed source and you don't really have the ability to, but not to mention it's so complicated you probably can't make changes to it very easily. Now in 1974, a very important ruling came down from the US Commission on New Technological Uses of Copyrighted Works. They deemed source code copyrightable. Up until this point, you actually couldn't copyright software. That's why it was all in the public domain. There was no way to go ahead and actually make it exclusive or to claim real ownership over it. Kind of like how today even recipes are actually not copyrightable. You actually can't copyright a recipe. That's why all those blogs that give you sort of instructions on how to prepare XYZ dish have to have a long personal story that goes along with it, because that part is copyrightable. The recipe is not. So as a result of this, now that source code could be copyrighted, this kind of planted the seed from which companies like Microsoft and others could grow and rise later. Because now they could go ahead and mark software as proprietary intellectual property and enforce it through copyright. Now, in the late 1970s and the early 1980s, up until 1983, there was a commercial software boom. This is when we saw companies like Atari and Apple and Microsoft and Oracle and others all emerge onto the scene. And as a result of this, open source largely became relegated to academia and the prior public art that was there. There was no mainstream open source movement to speak of during the sort of PC boom that happened right around this time. That was up until two key things happened in 1983. There was a court case, Apple versus Franklin, which determined that the compiled object code from Apple software was also copyrightable. So if the source code was copyrightable and you tried to reverse engineer that application from its object code, you were still in violation of the license. That's what the court found. So in order for you to have free and easily distributable software in the 1980s, the software had to be created from scratch as something that had a copyright and a license that allowed the source to be shared and modified. This is where Richard Stallman comes into the scene and creates the GNU and free software movements. And open source software starts getting distributed via BBS systems like shareware and so forth. And so back then we have sort of the early creation of GNU and some of the other sort of open source programs of the 1980s. But where things really started kicking into high gear again for open source was the first release of Linux in 1991. In my opinion, one of the big drivers behind the creation of Linux was the fact that Unix had been the source of a whole bunch of, let's say, corporate licensing and copyright issues from a bunch of different vendors. And so because of the prior art of Linux and its, not Linux, Unix and its source code all being kind of mangled in some of it's proprietary, some of it's not, etc., Linus Torvalds decides, you know what? I can work backwards from how the APIs work because those aren't copyrightable. And in fact, that got reaffirmed again recently with the Oracle versus Google lawsuits over the JVM. I can go ahead and create an implementation of the kernel APIs for the POSIX kernel. That's the kernel that sits at the heart of all Unix-based operating systems. So Linux, Unix, and even OS X all use this sort of POSIX kernel API. I can go ahead and build a free open source operating system on top of these kernel APIs, and that way we can be free from some of the licensing fees and also kind of the top-down proprietary development that was occurring here. And this was a pretty big revolution in that the development of Linux really created a platform, an open source platform by which all of these other open source projects that emerged during the .com era would be built. This includes technologies you've probably heard of, like Apache, Perl, PHP, MySQL, and more. All these technologies were all open source, beginning in really in the years immediately after Linux. And they became much more popular by the late 90s, as the .com and internet boom was really beginning to take off. So these technologies were developed largely in response to the fact that getting internet giants like Microsoft and others were very slow to take the World Wide Web and the internet seriously. So if you wanted to get rapid innovation and the ability to get into that space quickly, open source became the means by which this was done. And a lot of this technology was developed in platforms like Subversion and SourceForge back in the really mid and sort of late 90s. Well, by the time 1998, 1999 rolls around, Microsoft begins to recognize that they've been sleeping on the threat of open source, and they begin engaging in a campaign of FUD, which is short for fear, uncertainty, and doubt, litigation. In particular, they did this through the SEO Linux controversies of the early 2000s, and embrace, extend, extinguish, which was largely a measure to defeat open standards, in particular around the browser wars. This is back when Internet Explorer was vying for supremacy against Netscape Navigator and products like that. And ultimately, a lot of this kind of ended with the antitrust law, sort of decision that came down in 2001. Now, in the 2000s, open source successfully began to breach into the enterprise, largely as a response of the fact that a lot of rapid innovation was becoming available. These internet startups that had started adopting technology in the mid-1990s were now giant companies like Yahoo and Google and Amazon and others. And they had all been built on top of open source. So open source started making it into more mainstream applications like line of business software, not just customer-facing sort of internet and web applications. And then on top of that, businesses like Red Hat and SUSE Linux and the companies behind, and Canonical, all kind of started professionalizing the Linux experience from a system administrator, a professional support, and a maintenance standpoint. And these all kind of set the stage for open source to make a really big run at the really high dollar parts of the internet ecosystem. And then in the 2010s, this was kind of the beginning of the end for the proprietary software movement as it pertains to developer tools and building and basic application platforms. With the fact, with Java becoming open sourced officially, the JVM got open sourced not long after the Oracle acquisition. I think it might have been 2011 or 12 that began to happen. But in the culmination with that, and a slew of, let's say, Apache Foundation technologies all coming out around the same time, it was really the sort of mainstreaming of open source was really driven, in my opinion, by two things in the early 2010s. The first was the explosion of client-side programming frameworks, namely jQuery, kind of helping expose web developers to open source, sort of on the client side as rich web applications became more popular. But then it was also the NoSQL movement, which happened concurrently with that. In particular, it was innovators like MongoDB and CouchDB that really drove a lot of initial adoption there behind these technologies. And then later, in kind of the mid-2010s, we started getting really exciting DevOps tools. This is before the DevOps movement even really had a clear name. Tools like Docker and Ansible and Salt and others, Chef, Puppet, that all kind of began helping companies get more agile with deployments, helping them automate more things. And at this rate, the open source movement declared victory. Everyone uses open source today. And if your company doesn't, you should probably take a look at that. There's probably something wrong with your business, to be honest. Everyone uses open source because they want to benefit from the lower cost of ownership. You don't want to have to own every single piece of your stack. You don't want to have to pay licensing fees for all of it. But on top of that, you can benefit from the rapid innovation that's happening in all these different ecosystems all over the world if you use open source. So this is sort of where we are today. Open source is everywhere, and the open source movement beat the proprietary software ecosystem largely as a result of being able to out-innovate it and being more economical for end users. Now, some takeaways from history. Open source was initially defeated by proprietary alternatives because those companies that were building proprietary software were more efficient at recouping costs from their own development effort and reinvesting that back into the creation of the software. The whole Xerox PARC era of rapid sort of desktop innovation probably would not have been possible if all of that work was all open sourced from day one. Companies needed a commercial incentive to invent all these technologies and blaze the trail. But economics is not a static thing. Just because the ecosystem was one way for some period of time does not mean it will be that way forever. The tide began to shift in the 1990s because the economics of software development changed. In other words, what really changed was it got cheaper to build software. Let's take a look at Linux as an example. Linux was cheaper to build because in 1991, we already had the benefit of, let's say, decades of good practices for developing operating systems. That knowledge was available in the domain in the way that it wasn't in the 1950s and 60s. On top of that, Linus Torvalds and the other early contributors had the ability to benefit from some of the mistakes that Unix made. They could go ahead and rebuild a lot of the Unix APIs in the POSIX kernel. So they had a template they could work from. And on top of that, they had access to much better development tools in the 1990s than they ever did in the 1970s. They had better programming languages, better IDEs, development practices, static code analyzers, all that sort of thing. So as it became cheaper to produce software, open source began to become more attractive again. It could compete, in other words, with software that was built in proprietary ecosystems. But then in the 2000s, with the creation of proprietary software companies like JBoss, Red Hat, Canonical, and others, this started to really seal the deal. Now, there's one important thing worth pointing out. There's one area where open source was soundly defeated by proprietary software and still is to this day. And the answer behind that is in desktop user interfaces and even mobile user interfaces. All of those UIs are all still fundamentally proprietary software built by a small number of vendors. And the reason why? Well, even though the economics of software development changed in terms of being able to code and ship and implement and test, the economics of user interface development actually got a lot more expensive during this time because we had to support a larger range of form factors, a larger range of users, and we had to go ahead and support a much larger range of customizations users want on the user interface. So anyone who's done any serious amount of work on, let's say, a Ubuntu UI, which I use periodically from time to time, can tell you that that is definitely a cut below Windows 10 or OS X. So while the UI sort of story on Linux has gotten better, it's definitely a clear example of where the economics don't allow for it to compete at the same level as let's say, Windows or any other sort of proprietary desktop operating system does today. But in server-side environments, where you're building mostly web applications, you don't need to worry about that. That's why Linux and open source was able to compete very effectively there. And in general, most proprietary ecosystems can't outcompete open source. So I worked at Microsoft from 2010 to 2012, and I remember a bunch of our technologies that we used to try to compete with the open source ecosystem. Technologies like Dryad, which was our sort of high performance computing system designed to compete with the MapReduce technologies that were being produced during the NoSQL era. Other technologies such as, like some of the Azure offerings that were trying to compete with Apache Spark and so on. You can't outcompete with the rate of innovation that's coming out of the open source ecosystem on these fronts right now. It's stupid to even try. So the big takeaway is ultimately economics dictates which model works. At the end of the day, what developers care about is being able to deliver value to their users quickly. And whether they can do that by paying for licensing fees or doing it via open source isn't really it's not a philosophical decision for the most part. It comes down to economics and risk management. And so open source is the winner because it is a cheaper and more rapidly deployable way of going from nothing to something in the software ecosystem today. And it's much better at catering to a wide range of needs than a small number of proprietary vendors. So some statistics. Open source is now totally commonplace in enterprises. This comes from the To-Do Group survey from 2019. And let's take a look at the numbers here. Internally within the company, we use open source code for non-commercial or internal reasons. These are your line of business applications and that type of thing. 67% answered that yes, they frequently use open source for that. 18.5% said sometimes. And then let's see, the other about, looks like the other just under 15% here say they rarely or never use it, or they don't know. So we're looking at in the neighborhood of 85% of companies use open source for line of business applications. Roughly 75% of companies use open source inside their commercial products that they use to generate income for their business. And then there's a couple of other statistics here, but this is a pretty astonishing number that basically 3/4 of all businesses are using open source in some of their own products. That would have been unthinkable back in the heyday of maximum FUD coming out of Microsoft. So open source is now completely commonplace. And why do we adopt it ultimately? What are the business reasons that make open source attractive to us? Well, it comes down to these three. The first is open source allows us to reduce our costs. We can focus on our business, not on our infrastructure. That's probably the biggest argument. The second is security. In the event that, let's say, an open source project can't patch an issue that we have the ability to look at the code and fork it and fix it ourselves if needed. That's really powerful if you're running under a deadline and you want to have the ability to get to market quickly. You can still benefit from using the platform, but in the event that something comes up, you have the ability to go and contribute those upstream fixes. And then lastly is agility. By using this open source technology, you benefit from the bug fixes, updates, and feature releases that are contributed from a bunch of other users and a bunch of other companies. So this is kind of the wisdom of the crowd's argument for adopting open source. So all these ultimately translate into increased business value for organizations that use open source. So this is kind of where we're at with it today. Open source is largely ubiquitous. Everyone uses it. But if you take a look at this previous graph here, very few companies contribute code upstream. So very few companies contribute code upstream. Looks like about, let's see, if I total all these up and I included the rarely people in there, it looks like about 60 companies say they contribute code upstream. And bear in mind that they don't really specify the frequency, how often they do it. But very few train their developers to contribute to open source projects, and of a smaller number even go ahead and create their own. And this is what this sort of gets at the heart of our talk for tonight, which is that there are real business risks that come with adopting open source software. And these all come from the fact that someone is paying for open source, and it is probably not the users today. So the business risks of open source software. What are the things that you have to worry about if you're using it in your organization? Well, I sort of chalked it up into three categories. The first and also honestly kind of the rarest these days is intellectual property. So I remember an incident back in the early 2000s where an open source PDF filter had reverse engineered some code for one of Adobe's products. And so that's illegal, violates the licensing agreements of Adobe software. And that was incorporated directly into the open source library. Well, anyone who used that library was liable in the lawsuit that Adobe brought against the OSS organization and all of its users. That is a fairly big risk, but this is largely mitigated by having projects inside open source foundations. Your code gets run through essentially a type of sort of copyright checker where they can figure out if this code has any sort of stolen or misattributed code in it. I've seen some of the organizations that have adopted Akka.net have run this on our code base, and the .NET Foundation, when we joined it, also did this on our code base. Next is security. Malicious code can be pushed into a third-party dependency you rely on. I was trying to find a link for this, but there was a famous attack on a popular JavaScript library that's used in concert with a particular cryptocurrency wallet, where someone had contributed a piece of code that could leak the secure key needed to access that wallet. And it was a user who had a pseudonymous GitHub account who was given commit access to the repository, pushed this into this JavaScript that made its way out to NPM, the package manager for JavaScript, and a whole bunch of websites deployed it. And the user was the person who, well, the group responsible for doing this was going to try to go ahead and hijack some of the cryptocurrency that was available in users' wallets on those sites. This happened because the ownership of an open source project was transferred from a reliable party to an unreliable one. And that's actually a fairly sizable risk inside any project. That if the maintainers switch, they could go ahead and pull a bait and switch like that, potentially. But the more common and more substantial risks are the bottom two. First is lack of support. The open source project and its maintainers really aren't that responsive when you need help. So you go ahead and you start filing bugs and issues, and those just kind of languish. There's no triaging, no communication, only silence back from the project. That can be very frustrating. But the more severe and bigger problem I highlighted here is abandonment. What happens when a popular open source project that you depend on, that sits at the very foundation of your work, the founder, let's say the maintainers, just completely walk away from it? Well, now you're stuck with a piece of abandonware. And if you have, let's say, major parts of your infrastructure running on that, this might make it very difficult for you to do things like upgrade to a newer version of .NET Core, or be able to go ahead and move from Windows to Linux, or it might even make it difficult for you to hit your performance goals, because now the downstream sort of dead project can't receive those forks and can't receive those updates and regular maintenance anymore. And this is actually a fairly common problem, even for popular projects. So popularity is probably one of the biggest measures that people use for gauging whether or not it's safe to take a dependency on something. And that's actually a pretty poor measure for assessing the risk of a specific project. So based on this study, I'm going to reference the study a couple times here. Based on the study here, they took a look at about 2,000 really popular projects on GitHub. And about 16 of those projects face at least one, this is a TFDD, which is short for a truck factor disengaged developer. Means that one of the core maintainers just walked away from the project and it just languished, abandoned. And the reason why this is such a problem is the truck factor, which I'll explain in a moment. Well, I'll explain it now. The truck factor is how many developers need to be hit by a truck in order for this project to become abandoned. So a truck factor of 1 means that there's a single point of failure in the project. If that one developer leaves, no one else has the keys to deploy new versions of the software, and the project's going to die. So a truck factor of 1 is high risk. So 66% of these incidents of popular OSS projects having a developer leave happened with projects that had a truck factor of 1, and 55% of all popular open source projects have a truck factor of 1. I'm going to show you some more data on that in just a second. So popularity is not necessarily a guarantee that that project's going to stick around. Now for .NET developers, you know what else is a guarantee that this project isn't going to be abandoned? The fact that Microsoft made it. So I decided to go ahead and just very casually take a look at the Microsoft GitHub repository. And I wanted to take a look for projects that Microsoft had actively recommended to their end users. Like, these were real frameworks, not examples or toy repositories that had just some samples for one, let's say, build conference or something in it. No, these are like real frameworks that they were recommending to their end users. Here's just a cherry-picked sample of a handful. They've got 3,500 projects on just the Microsoft organization. Bear in mind, they also have the Azure organization and the .NET organization as well. So the Distributed Machine Learning Toolkit, 2.8 thousand GitHub stars. Last updated July 2017. They haven't even renewed the TLS certificate for their website. It's been expired for at least a year. Visual Studio Tools for AI, 317 stars, abandoned in 2018. YAMS, yet another microservices solution. They've given conference talks on this as recently as a couple years ago. Abandoned, July 2018. Code contracts, I use this inside some of my projects. Abandoned, March 2017. XUnit performance, etc. I could probably go through and find, if I really wanted to, I could probably find 100 examples of this in Microsoft's organization. And so just because Microsoft builds a framework, open sources it, and even starts evangelizing it, is no guarantee that they're not going to abandon it and turn it into abandonware later. In fact, I'm going to bring up a very specific case study that affects me and my business of how that happened. So the factor that we want to look at for how risky an open source project is from a sustainability point of view is the truck factor. How many people need to be hit by a truck in order for this project to fail? This is a graph of truck factor numbers for major releases of AngularJS in 2016, which was probably at a point where Angular was really taking off in popularity here. So bear in mind, this is a Google-supported project. It has the full resources of a $1 trillion company behind it. The highest truck factor ever achieved was 6. There were a number of releases done with 2 or 1 developers during the span of time. So Even Google, with all of its resources, has a very small number of developers who are so key to the project where if one of them leaves, a ton of inbuilt knowledge, and not to mention a deployment tools and access just walks out the door when that happens. So low truck factor is a danger sign. Most projects, most popular open source projects have a very low truck factor. So 57% have a truck factor of 1, 25% have a truck factor of 2, and the highest truck factor when they concluded this study was 26 developers. And bear in mind, this study included projects like Docker, Kubernetes, and others. When I saw the numbers for Docker in this paper, I think some of the study was done, I'm not sure of the year on this one. This was done in 2016. When I saw the truck factor graph for Docker in here, it had 10 people on it. For a piece of infrastructure that is so heavily used around the world, I'm honestly kind of surprised that there's 10 people who are so critical to that project that if all of them left, it would just fail. That seems unimaginable to me, given how prolific Docker's usage is. So there's real risk everywhere in the ecosystem of projects being abandoned as a result of these critical maintainers no longer being available. But I'm going to go ahead and color this picture a little bit more and talk about why Docker and Kubernetes and projects like that are probably going to be okay, but why some other projects that might have some of the same characteristics as them aren't. So why do these risks of abandonment and malware and so forth occur? Well, the problem is that these open source projects are widely used by a large number of users, but there's only a very small number of developers who are capable of doing the core maintenance, updating, and development on these projects. So you basically have this kind of a lot of pressure being put on a very small resource, and that resource is finite. And these core developers have very valuable knowledge and are very expensive to replace. So the problem, ironically, gets worse the larger and older the code base is. So a lot of the projects that have been abandoned on that study that I linked to were projects that were between 5 and 7 years old. Younger projects actually had a better chance of being able to survive a developer leaving the project and some new maintainer coming in to replace it. And the reason for that essentially comes down to the code bases typically grow larger in size and complexity over time. Newer code bases tend to be a lot smaller. Now, the other issue in terms of why these risks occur with open source, it's not just that you have a very small number of individuals who are kind of the key players in these open source projects. It's also the fact that these individuals are largely unpaid volunteers. So you get what you pay for. In a project that gets really popular, where the developers are working for free in their spare time, you shouldn't be surprised when the support sucks, or the documentation is out of date, or there's not a lot of, or there's, let's say, no clear time frame when there's going to be a new release on the milestone. And this problem gets worse the more successful the open source project is, because the more people there are demanding time in the form of bug reports or feature requests from the small group of unpaid maintainers, the more scarce and the more sparsely allocated their time becomes across all these different issues. So the more successful the project is, the more expensive it becomes to maintain. And that's really the fundamental problem here, is that we have a tragedy of the commons issue from an economic standpoint. So a tragedy of the commons is an economics idea that dates back to the 19th century. It tends to come up in environmental policy quite a bit. So a good example of tragedy of the commons in, let's say, 2020 would be something like overfishing. There's this common stock of, let's say, snow crab in Alaska. And without the Fish and Game department essentially regulating how much you can catch each year and which types of crabs you can get, we would eventually deplete that resource because it costs these fishermen nothing to farm more and more and more of it until they deplete it to exhaustion. And that's one of the cases where government regulation can actually help, and from a economic standpoint. Now, the different open source project types have different risk levels, and this is something that we want to take a look at. And I'm going to get down to some of the details on this in a moment. But hobbyist projects, these are projects that are done solely at the pleasure of the original creator. Let's say, for argument's sake, I'm really into home automation and I like programming with Arduino, and I go ahead and I create a framework for, oh, I don't know, building lighting systems using Arduino, and that has nothing to do with my day job. And I don't make any type of money from it at all. I just put this on GitHub because I think it's fun, and I'd love to see if someone else would use it. You should absolutely use those types of projects at your own risk, because the hobbyist programmer is doing this just as a hobby. They're not going to necessarily provide, a same-day SLA support SLA for you. That's not the reason why they're doing this. Their incentives are not aligned with yours as a consumer at all. So this is the highest risk type of project to adopt. And when I say risk, by the way, I mean the risk of the project being abandoned and you get stuck depending on something that is no longer maintained. That's what I mean when I say risk. But also the risks of things like, let's say, the owner giving, let's say, an untrustworthy actor the ability to basically push commits into the code base. Those also tend to increase here because the hobbyist has less skin in the game than, let's say, someone who runs a professional open source project. So the next level of sort of project type is what I call the side gig. This is an instance where you have a developer who creates an open source project designed to solve some problem they have on the job that they have right now. So a good example, if I go ahead and create, let's say, a tool for being able to configure monitoring instrumentation for my ASP.NET Core application, I go ahead and talk to my boss, and they decide that maybe it'd be worthwhile to go ahead and open source it. And I go ahead and I open source the code, and I start accepting some commits to it, and I do things that can make it better. But really, what matters to me is my day job. And being able to work on my little side project here is fun and interesting. But if I leave that company and I go take a job as a Scala programmer somewhere else, I'm probably not going to maintain this anymore. So a change in careers or change in jobs or even a change of positions within the company can actually go ahead and threaten the long-term stability of this type of project. Now, I would argue that where most people get burned by open source abandonment is actually the ancillary projects down at the bottom here. And this is because they look safe. Ancillary projects were originally a component of a paid product or service, but they were open source separately in order to benefit from community adoption, maintenance, and contribution. Akka.net actually originally began this way. We were building it as a system for being able to run our marketing automation technology at a previous startup about 7 years ago. It's now a professional open source project, which is the last category I'm going to talk about, but it originally began this way. Ancillary projects are still risky because the priorities of the business can change. So for instance, this product could be deprecated, or the strategy that we're going to use for selling it might change, and that might threaten the open source that goes along with it as well. The most safe type of project to adopt is the final one, professional open source projects. And the reason why, I'll get into this towards the end here, but the reason why they're the safest types of projects to adopt is because the incentives of the maintainers of the open source project and the incentives of the consumers are fully aligned. The open source developers want users to successfully adopt this project and deploy it because that somehow translates into return on investment and revenue for them, which in turn they have to reinvest some portion of back into the open source project in order to grow it and to retain customers and to gain new customers down the road. So you end up with a positive feedback loop down here. In all of these other sort of project types up here, there isn't a positive feedback loop. The project actually can get more expensive for the original developer to maintain the more people that use it. And that's a problem. And that's really the source of the sustainability crisis, is the fact that most projects are not organized in a way where the incentives of the consumers and producers are aligned. So I'm going to go ahead and use a little abandonment case study that is near and dear to my heart. This is .NETty. .NETty was a project that was originally open sourced by the Windows Azure IoT group at Microsoft. We use it to power the networking layer inside Akka.net, the professional open source that my company helps produce. So this powers our networking systems. And we originally had our own networking software that we wrote ourselves And we went ahead and deprecated that in favor of using .NET because we figured it would be better for the community to converge on a single solution, and we trust the quality of Microsoft's engineering. Well, here's what happened. This was originally developed by the Azure IoT group, and this product, I should mention, by the way, is still actually used inside the Azure IoT protocol gateway. And I think one of the SDKs that the Azure group makes available for IoT programmers in C#. So this open source is still actually used inside Microsoft's own products. But lo and behold, the project was effectively abandoned as of October 2019. And the last major NuGet release was in late 2018. And this project still gets 1,500 daily installs on NuGet. Now, why was it abandoned? Well, the rumor that I heard from the actual original creator himself was that the Azure IoT team behind the scenes was beginning to experiment with Rust. And they were going to use that to try to speed up the actual processing times of the Azure IoT gateway. But as a result, all the people who use .NET under the covers, which includes Akka.NET and a number of other different open source projects, we actually can't push updates without having to fork it. So .NET was originally an ancillary project. It was part of the componentry behind both the server side of the IoT hub and the client side of the IoT hub. Now, .NET is still part of the client side of the IoT hub today, but the original developer who maintained it was primarily a server-side developer. And as a result, the risk profile when we originally chose to adopt it looked pretty good. And it even still looks good today. .NET is part of the Azure organization, and it's included inside Microsoft's products. It has all the signs that should make it look like it's a fairly low-risk project to adopt. But here's the problem. Even though .NET had a pretty good-looking risk profile from the fact that it was developed by Microsoft, using their software, etc., the problem that it had was it still had a truck factor of 1. There was one core developer at Microsoft responsible for maintaining it. And then when his projects and his priorities changed inside the company, no longer had time to work on .NET anymore. And as a result, since October of 2019, there's been no triage from any of the maintainers. There's probably at least half a dozen issues on the .NET GitHub right now asking, is this project abandoned? There's tons of unmerged pull requests that include fixes and other updates. And then I've personally tried to get a hold of the maintainers via email to ask if they would be interested in transferring the project into the .NET Foundation and letting other people contribute to it. And we've gotten back largely radio silence so far. So here is what I have to do as sort of the release manager for Akka.NET, because I have a responsibility to our users to deliver the best experience possible. And that means being able to go and fix issues that we can trace back to .NET somehow. And right now, I have no means to do that because I can't get a hold of the people who control the NuGet publishing key and the source control and all that stuff. So what are my options? Well, my options for replacing .NET as a product owner is to rewrite the entire networking engine using system.io.pipelines, Project Bedrock, or something else like that. And I call this a high uncertainty operation because I have to find a way to do this while recreating all the functionality that current Akka.NET users already depend on. We have to make the upgrade seamless for our end users. Part of having a professional open source project means guarantees like semantic versioning and backwards compatibility get honored. So that's something that you get from a professional open source project that you probably wouldn't get from a hobbyist or a side gig, is that level of sort of engineering quality to go ahead and make sure that users can upgrade smoothly and have a good experience doing it. But then the other issue is I have no idea what the performance is going to look like if we go and replace all of this code using Project Bedrock or system.io.pipelines. So that might mean, oh, we lost an order of magnitude on performance, or we might even gain an order of magnitude. Who knows? But anyway, that's just a bit of uncertainty that we're going to have to work around somehow. And then, by the way, we might also find ourselves in this exact same position 2 years from now if Microsoft deprecates pipelines and comes up with something else that's new or whatever. The other approach we can use is the tried and true method for what happens when an open source project gets abandoned, which is you fork it and then you replace the packages with your own. And so that's something that we could do. We could go ahead and fork .NET, rename all the NuGet packages, create a new open source organization for it. And that could be really expensive to do. The whole reason we adopted .NET in the first place was to avoid the costs of doing this. But if there's a bunch of other users who are all depending on .NET, who are, let's say, co-invested in maintaining the project, we could potentially have multiple maintainers start working with us, and we could raise the truck factor on the project if we wanted to. But this would ultimately turn .NET back into yet another ancillary technology. It wouldn't be a professional open source project the same way that Akka.NET is. So this is sort of where the root of a lot of the problem and risk comes from, is the fact that there are real business risks with open source, and those business risks are that the people who are responsible for being able to press the publish button can walk away from the project and you won't be able to get a hold of them again. So why does this happen in the first place? Why do projects get abandoned? Why do people walk away from these projects they've invested so many years of work into? Well, the answer is that typically the incentives of the people who produce the software and consume it aren't aligned. So reasons why projects get abandoned. So in the Akka.NET project, we've probably had, over the past 7 years, we've probably had in the neighborhood of 12 to 15 people who I would call core developers on the project. These are people who really know the guts of the system inside and out and can make really substantial changes to it. Well, the reasons why some of those people left the project over the years can be found right here. Maintainer burnout and detachment's a big one. It's actually intellectually expensive to go and triage a bunch of issues out in the open in public, to go and review pull requests, to have to make decisions about what features should be included and which ones can't. And saying no to people is hard. It's one of the things I have to do all the time as a maintainer. And that can be very tiresome, particularly if you're doing it without getting paid. Next, loss of interest. In a lot of cases, developers were really passionate about some project they started. They worked on it for a number of years, and then they found something else that was more interesting to work on. So they just kind of left the project behind because it didn't bring them joy anymore. And there's nothing wrong with doing that. They have every right to choose how to spend their time. No one is entitled to a maintainer's time if they're not paying for it. But then I'd say the most common reason that we've lost people in our project in terms of the sort of third-party contributors is usually they change jobs. They would go ahead and change from a role where they were doing a lot of concurrent programming in .NET to doing, being a project manager a product manager at a company. Or maybe they switched to doing JVM programming, or they became more interested in doing Node.js and that type of thing. And that's another reason why a lot of, let's say, key developers in the organization can leave. And so when enough of these happen, though, when the truck factor gets down to 1 and that person leaves, that's when the project's in real trouble. Now, one of the things that can accelerate maintainer burnout and loss of interest is when a project becomes a victim of its own success. So there's a scale problem that comes with open source, which is that the more popular an open source project becomes, the more expensive it becomes to maintain. There's sort of a through line that looks like this. Now, the reason why those projects get more expensive to maintain is because the number of issues you have to triage, the number of different types of users you have to support, and the number of different constraints that get imposed on you through obligations like backwards compatibility all increase. So here's a good example with Akka.NET. We just upgraded in Akka.NET 1.4 earlier this year to .NET Standard 2.0. I would love to be able to go ahead and just move everything onto .NET 5 so I could try to get the absolute maximum performance out of all the I/O components in Akka.NET. But I can't do that. The reason being, we have a ton of customers, paying customers, that all depend on .NET Framework 4.6.1. And they're probably going to be stuck on that for 2 to 3 years. And we have to have a plan for going and supporting all those customers. And, ultimately, the way that ends up working out for our project is the fact that since a lot of those users are actual real paying users and we care about them being able to get the latest updates and fixes, We were able to go ahead and foot the bill from a development standpoint to have a strategy that allows us to accommodate them. And we're probably going to go ahead and use something like pre-compilation macros to build a version of Akka.NET that can also target, let's say, .NET 5 or .NET 6 when that comes out, so we can target all those high-performance APIs. But if we didn't have any of that commercial support behind us, doing this would be very expensive. We would essentially have to foot the bill doing all this using just developer time. And that's a very expensive proposition. So adoption risk in terms of the likelihood of a project being abandoned is really driven by the lack of project plus business alignment. And here's what I mean. The lower returns to the maintainers, meaning that if maintainers aren't incentivized to try to solve the problems that end users present, a good example, issue triage. If maintainers aren't incentivized to do that, if the only reason they want to respond to GitHub issues is so they don't feel bad or so they don't look bad, and they don't have any, let's say, positive reasons for wanting to encourage that, these are all going to lead to to an increase in detachment from the project and maybe even resentment towards its success. But on top of that, if the returns to maintainers are low, the maintainers are going to put less effort into things like professional product management. So good example, preserving backwards compatibility and honoring SemVer guarantees in a way that's not ridiculous. So an example of what unprofessional product management looks like is every time there's a breaking build in the software, the developer just goes and bumps the major version. And so they produce, let's say, 2 major versions of the software every month. Well, at that rate, I don't want to invest all this time as an end user into having to learn each new version of the software that comes out every month. So I'm just going to go ahead and freeze my version and basically just stick with that and probably just go ahead and ignore all those upstream changes. That's really not professional product management. You're not including a path for me to get onto the latest version and benefit from all these design changes you're implementing. You're just kind of throwing stuff at the users and seeing what sticks when you do that. Then other things that don't happen when you have no project plus business alignment, you don't have application of engineering best practices. You don't get a lot of documentation or examples. And you definitely don't get regular updates or continuous integration, although often you tend to get more sporadic releases. But I'd say the biggest thing you probably lose with that lack of alignment is you lose frequent communication with consumers and contributors. That's something that really suffers when there's a lack of alignment between consumers and producers, because the producers look at communicating with their end users as just a cost. That's all that it is. This changes when we introduce alignment between producers and consumers. So we have our graph from before of the costs going up for maintaining a project. And by the way, this graph is not to scale. This is just to illustrate an idea. But when we have business alignment in the picture, meaning that as the number of adopters increases, the amount of potential return on investment maintainers can get increases as well. We reach a break-even point along the way where eventually the maintainer can do things like replace their own income with income they get from the open source project, or they can even increase the truck factor by hiring other people, which is what we've done at Petabridge, for instance. We have a team of 2 other developers who work full-time with me on Akka.NET. We're probably going to be adding another one later this year too. So that type of business alignment helps increase truck factor, which helps make the projects more sustainable, which helps make them more professional for end users. And in fact, here's what that virtuous cycle looks like when we have full alignment between the producers and consumers of open source. So the users adopt an open source library or a framework of some kind. The users discover issues and begin requesting features. They basically start making asks of the actual producers of the open source. And those maintainers promptly triage those issues and communicate with the end users, because it's in their financial business interest to do so. It's in their interest to try to bring people into the project and to try to win their support and to try to get them to adopt whatever the open source technology does. And then if the users have a good experience, basically they build up some confidence in the open source project, some of those users will purchase services and goods from the maintainers. Now, the users don't purchase those services and goods out of the kindness of their own heart. They do it because those services and goods they're purchasing actually go ahead and accelerate their own time to market or improve their own return on investment and the open source somehow. So a good example, I'm doing trainings for Akka.net this week. The reason why our customers pay for those is so their developers don't have to spend months learning how Akka.net works. I can go ahead in the span of about 3-4 hour long courses, teach them the ropes and get them up and running, usually within a week or two. And so on top of that, once the users begin purchasing services and goods from the maintainer is incentivized to regularly update the software, to update documentation, to create tutorials. And this creates a virtuous cycle that attracts even more users of the platform because the project's reputation increases. And this is what a full alignment of incentives looks like inside an open source project. Now, to be a little self-critical for a moment here, here's an example of where my company has alignment on one project, but not on another. So I have NBench, our performance testing system on the left, and Akka.net, our distributed actor framework on the right. I love both of these projects, and I like working on each of them, but here's the issue. NBench is an ancillary project. We use it for measuring the performance of Akka.net, some of the other technologies we make, and the updates to it are pretty sporadic. It has a low truck factor. I'm really the only developer who's ever worked on it. And it consists of exactly 0% of our revenue. And that 0% of our revenue is probably why the updates on it are sporadic and why I haven't hired any full-time developers to go and work on it. I haven't really gone out there and tried to sell NBench trainings or support plans or proprietary tools. Just hasn't been on a priority for me in my organization. Akka.net, on the other hand, is a professional open source project. We update it frequently. We have a higher truck factor, which includes, myself and 2 other full-time employees who, make our rent based on how well Akka.net does. And it's about 95% of our company's revenue. So we are very strongly incentivized to make sure that Akka.net issues get triaged, that we update bugs, obviously that we fix bugs, that we add new features, that we update the documentation, and we're always trying to get better at doing this. And as a result, we also go and develop really good professional practices around managing things like the integrity of the API, managing the documentation, trying to go and produce new materials and YouTube videos and that type of thing. These are all things that happen when the incentives between us and the people who use Akka.net are in full alignment. And you know what? I'd say 99.9% of our users probably use Akka.net and haven't paid a dime for anything because we give away a ton of things for free. But that's okay. We only need to make basically money off a very small number of, let's say, customers that are using Akka.net in really critical areas of their application to build a sustainable business out of it. That's sort of where the scale comes from here. So from a risk perspective, adoption risk on the left, project plus business alignment on the bottom. A hobbyist project is the absolute highest risk because there is zero alignment between any of the parties here. That's the issue, which is that the maintainer totally wants to do their own thing, doesn't want to be bothered by end users. And meanwhile, the end users want to start requesting features and getting bugs fixed, and they want new releases. And the maintainer's just not that interested in it. This is their project. They're going to do it their way. Next, we have the side gig project. Things are a little bit more aligned here. This side gig project does have to maintain some professional standards since the maintainers are using it at their place of work. So it's going to be, probably have some better documentation, better testing, better continuous integration than a hobbyist project might have. But you're still at risk of that developer changing jobs and just walking away from it. An ancillary project's even a little bit better than that. This was originally part of our product, so it's got product grade engineering behind it. It's originally meant to be part of an organization that's trying to profit from the use of this software. And so they're going to be really strongly incentivized, at least in the beginning, to make this really, really good under the covers. But the lowest risk is going to be a professional open source project because this project on the bottom lives or dies by how many people adopt the software and by what percentage of those people who adopt the software end up buying services or some other type of good produced by those developers. So that's really sort of where the rubber meets the road from an alignment perspective. Now, we have a small problem though. This is all good in theory, but here's what the reality looks like. The reality is that both maintainers and users of open source have done very little to create alignment between each other. In the open source world, most users are free riders. They don't contribute back code, they don't pay, they might file bugs, which in my opinion is still a really great form of contribution. Helps me figure out what sorts of issues might be affecting our customers. So I really appreciate that. But they don't really contribute code back, and they don't do anything to try to help raise the truck factor. On top of that, most companies don't budget for open source. They don't budget developer time for contributing back. Some organizations even have really draconian intellectual property restrictions that actually legally prevent them from contributing back. This is actually one of the things that .NET Foundation really helped with in the very beginning, was they're able to create some agreements with some of the largest users of .NET and the ecosystem. So some of the big banks, healthcare companies, that sort of thing, that made it possible for any of their employees to contribute back to a .NET Foundation project, and all of that, all of the sort of company's legal sort of claims to ownership over that code were waived. That's something that an open source foundation can do really well, and I don't think they've been doing as much of that lately. Lastly, most companies that I know of most companies that I know of that aren't our customers don't really budget very much for open source. They don't budget money for support plans. They don't budget money for training. They kind of view open source as this free thing they can get, and they're just going to go ahead and kind of use it and try not to worry that much about it. That's one of the problems we have to address in order to solve the sustainability crisis. Next problem is the maintainers themselves. I have watched a bunch of maintainers trying to figure out how to solve this problem of how expensive it is to maintain software. And the number of them who've come up with the earth-shattering idea of charging for their time is pretty close to zero. Not exactly zero, but not that far away from it. Maintainers have put very little effort into giving users something they might want to buy. So, for instance, they haven't really done a lot of work to offer support plans, which is probably the easiest thing you can sell if you're an open source developer. Support plans are great because it's basically like insurance for the users who want to buy it. They have the ability to get a hold of you under a service level agreement, usually one day via one business day via email. And they can also get things like patch priority. Any bugs that our company runs into with the open source get moved up to the front of the queue. That's a pretty easy thing to sell to people who are really invested in the open source. But even then, most maintainers don't do it. And then more serious open source projects might do things like build proprietary add-ons. So for instance, Identity Server, which is open source and free, has Policy Server, which is a proprietary add-on you can use for creating identity policies on top of Identity Server. That's a great example of a proprietary add-on, for instance. It can be kind of expensive for a maintainer to create the infrastructure needed to go and sell all these support plans. And fundamentally, it's actually a little risky for maintainers because effectively what you're doing when you do this is you're starting a business. And as a two-time entrepreneur, I can tell you that that is a fair amount of work, and not everyone should go into open source. Not everyone should go into open source planning to start a business. It's a big time commitment, and there's a lot of complicated stuff that comes up with it. But that's what you basically have to do in order to create a project that is sustainable. Now we're going to talk a little bit about some of the different solutions to these problems next, the good and the bad. How do we help open source consumers and producers align incentives so we have that virtuous feedback cycle? Consumers get their bugs fixed and triaged, and they get the new features they want, and they get good documentation. Open source producers get return on investment, usually in the form of income, but maybe it's in the form of prestige and other things they might care about. But usually it's going to be income is what they want. Well, I'll give you an example of a really terrible solution, which seemed to be the first one that the open source community jumped onto, which is donations. Donations is a beyond terrible solution for this problem. Here's why. They don't work. So Who remembers the Heartbleed blog from 2014? This was a SSL vulnerability in the OpenSSL package, and it exposed thousands of businesses, including giants like Amazon and Facebook, to this massive security vulnerability. Well, guess what? OpenSSL received about $2,000 a year in donations, despite being one of the most widely used and adopted open source projects on the planet. And, you know, even companies like Facebook and Google and Amazon and others were all just free riding on OpenSSL. And then guess what? After Heartbleed, when all this attention was put on how low the truck factor was for the project and how few dollars were being used to support them, guess how much amazing money OpenSSL was able to raise via donations. Bear in mind, this is after this Heartbleed blog basically shut down like internet infrastructure for a period of time. They were able to get that number up to about $9,000 a year. That's not enough to really move the needle. Once you can't even hire a software developer for 3 times that. That's not really getting us anywhere. Donations don't really scale all that well because they are so few and far between, and because there isn't really alignment with them. Donations are something you do as a form of charity or support primarily. What works better is when you actually have incentives to go ahead and buy things and get something back in return. That's why donations don't really scale. The math doesn't really support that at all. And there's tons of examples of them not working. A better way of trying to address the sustainability crisis is to create company open source programs. These are programs that leaders in your company can go ahead and craft, or you can go ahead and start pushing for this inside the company yourself, to essentially create a culture within your business of contributing back to open source. You can contribute code or documentation, or maybe even do code reviews. And this will help raise your level of awareness of how the different dependencies that you use work. And it'll go ahead and help improve the types of patterns and practices your own company uses. And it'll give you a chance to make the projects you work on more sustainable. I'm thrilled whenever I get pull requests and bug fixes on Akka.net. That's a big in-kind contribution to my customers and all the free users that use Akka.net all over the world. So this is a really beneficial way of doing it. Now, as part of open source programs, what these programs typically do, the company will go ahead and allocate a certain amount of developer time to contribute to open source. So meaning that the time you spend, let's say you're at a company that uses Akka.net, the company might give you, let's say, 2 weeks out of the year to go ahead and work on fixing bugs and performance issues that directly affect your business's use of Akka.net. This will give you an opportunity to learn how the Akka.net codebase works. You can learn best practices and patterns from the other maintainers and users of the software, and you can even learn new tools. So for instance, you might learn, if you worked on Akka.net, you might learn how a tool like Incrementalist, NBench, or Azure DevOps works, for instance, or FSCheck, that'd be another one. The other thing that company open source programs can do is they'll begin, and this is kind of a newer thing, some of these programs have started to allocate money towards open source foundations. So becoming a member of an open source foundation is one thing some of these organizations will do, or they'll offer open source grants towards projects they depend on, using a platform like Open Collective or GitHub sponsors to do it. Now, I just said that donations is not scalable, and I don't think it really is, but you know what? Any little bit can help here. And I think what foundations really kind of help open source projects do is they, make it possible. So let's say in the event, let's say if .NETty was inside the .NET Foundation, if all the contributors from Microsoft left, the .NET Foundation has admin access to that project, and they could add myself and maybe a couple of other maintainers that they trust from inside the .NET Foundation membership to take over authorship. That would go ahead and solve some of the abandonware problems that particular project has. So foundations can do some good. Not all foundations are equally effective, though. I think the .NET Foundation in particular is in a place right now where it kind of needs to figure out what it's all about. It started off really strong when it first came out a couple of years ago, and I think more recently it's kind of struggled to find its footing. And the .NET Foundation elections end tonight. So you should go ahead and cast your vote in the next few hours here if you haven't already. Now, another good solution, aside from creating an open source program at your company, I think everyone should definitely do the former. The latter solution here is for the different open source projects that you depend on, particularly the ones that are really critical to your application. You should go ahead and take a look at whether or not it'd be worthwhile to buy goods and services from the maintainers of that open source. So for instance, getting additional value by having training for some of your developers. That way they can learn all the best patterns and practices for working with that open source tool. This can help improve your time to market and help reduce mistakes. You can also get things like support plans with some service level agreements. That way, in the event that something goes wrong, you can go ahead and get support exactly when you need it. We had a customer last week who's been a support customer of ours for at least, 3 years. And they went ahead and filed their first support ticket because as their system's gotten bigger, it started running into some stability issues with their cluster. And they were able to go ahead and get a resolution from us within a couple of days. We had to have a few round trips of looking through log files and stuff with them, but we were able to really help them when they were in a jam. That's the benefit of having something like a support plan. It's there when you need it, and you can get a same-day response with the service levels that are usually added onto those. And then getting patch priority and open source updates can be really helpful. But then the other big benefit of doing this is that this ensures the longevity and the higher truck factor of the open source that you adopt. If you go ahead and basically maintain the support plans and get value out of them as an organization, you're also helping make sure that you're going to get more features and more tools and more documentation, other things that you need. So by not being a free writer, you can go ahead and make sure that the open source that you're using is going to stick around because the people have a commercial incentive to respond to your support tickets because otherwise they won't have your business anymore. But on top of that, this will help guarantee that the actual projects get maintained and that there's always someone working on it, and it'll keep the truck factor higher that way. So lastly, for maintainers, we need to start selling stuff that people can buy. That's the number one. I think that's honestly the number one thing. It's not all on consumers and consumers not wanting to pay for stuff. A lot of it also is the fact that we haven't been very good at even attempting to have this conversation with our users. So we really need to start selling services. So these should probably start with things like support plans that include service level agreements and patch priority. The thing that we used to originally start Petabridge back in 2015 is we sold live training via webinar. Perfect time to do that right now, by the way. So that's another thing you can offer. And by the way, these are both very low cost to entry sort of services you can sell. It takes basically a Zoom account and a Freshdesk account to go ahead and do this. A more expensive approach would be to develop open core products on top of your open source. These are proprietary add-ons built on top of the open source that you already maintain. That's a little bit more risky because you actually have to invest a lot of R&D into doing those. And then finally, this is a new project that my company is working on, SDK Bin. It's basically NuGet meets the App Store. It's designed to help drive down the cost of sale to make it easier for you to sell support plans and to renew them with your customers without having to go and create your own billing department and without having to hire a salesperson. You can basically go ahead and point them to your SDK Bin website. They can run a credit card through it, and you can go ahead and automatically fulfill your order without needing to even talk to your customers necessarily. That's something we're still working on. We're planning on launching it on September 30th. So these are some things that we can all start doing to try to help solve this problem. Now, let me go ahead and end with a warning here. This is where I talked about the coming crisis. This is what the crisis will look like if we don't change our behavior. OSS maintainers are starting to realize that they wield a lot of power and influence over the people who use their software. And they're starting to take a look at, well, let's see. I get companies that do $10 billion a year in income demanding free support from me. And in return, I have to basically take away an hour of playing with my kid in order to look into fixing that problem. And I am not particularly thrilled about that. So the culture of free writing is something that is being put on notice by a large number of open source maintainers and companies across the board. That if your organization continues to make, or if you continue to make demands of let's say the time of maintainers and the people who work on these projects without contributing anything back, eventually that free riding culture is going to come to an end because the economics are going to shift once again. Just like how I talked about at the beginning of this presentation, the pendulum could swing back the other way, back to proprietary software, because the economics of open source have become so distorted away from the people who are footing the bill for developing them right now. And if that happens, what's gonna, basically, if that happens, what's gonna ultimately end up happening is that open source is gonna become a lot less open and a lot less free. What you'll start to see is the emergence of much more draconian licensing schemes. You'll start seeing open source projects intentionally closing many things off or delaying releases to non-paying customers. And the open source ecosystem will become a much less free-flowing place where you can get patches and support and communication for free out of sort of the, let's say, the community spirit of trying to make the program better. It's going to start to be run much more ruthlessly if the status quo does not change. Because the people who have a lot of power and influence here are also the people on the bottom of the economic totem pole right now with respect to open source. And they know it, and they're going to start doing something about it. So the thing that we should try to do is, we should help maintainers create sustainable models for their projects. And if we take a look at the open source technology our businesses use, we should go ahead and try to find a way to go and support the maintainers of those technology. Very recently, for instance, we use an open source technology in one of our paid products that we sell. And I recently reached out to the developer and offered to go ahead and pay him to do some contracting work to actually improve the performance on the open source library. He declined due to some work that he's got going on with his day job right now, but otherwise he'd probably take it. That's an example of the type of thing where there's a win-win opportunity there, where we get much better performance out of the library that developer originally created. That developer gets paid to make that library even faster, something that he would love to do in his free time, but he's also got to find a way to make his rent too. And so that's the real lesson here, is that incentives matter. And we have to look at trying to align incentives between open source consumers and producers, or ultimately what's going to end up happening is the ecosystem is going to shrink, and it's going to be a lot less open and a much less free place. So thanks for listening today. I'd be happy to take some questions now. And I have some links here you can use for further reading if you wish. But thank you very much. Okay, questions on the Q&A panel. Paul, I'm going to go ahead and answer your question live. Okay, Paul's question is, how can you spot a project that is risking abandonment? Do you need to know about the internals of the project's creator organization? That is a fantastic question. Well, let me go ahead and take a look. I'm going to go ahead and pull up aka.net on screen here. So one of the settings you can look at for a project that's on GitHub that's very useful is the Insights tab. And so if you go ahead and take a look at Insights, here's a couple of things you should look at to kind of gauge the health of a project. This list right here, this is sort of the summary for the past week. 4 authors have pushed, 4 commits to dev, and the number of files doesn't really matter. But the fact that there's multiple people sending pull requests is a very good sign. Means that you've got, let's say, it means that the truck factor is probably higher than most. If you scroll down here, you can take a look at pull requests being merged by different people. You can take a look at different issues and everything being open. And what you really want to see is you want to see people responding to issues being opened, and you want to see multiple people all contributing code. Those are all really good health indicators for a project that's in good shape. For a project that's not in good shape or at risk of being abandoned, I'll go ahead and use one of our abandoned plugins. And here, this is an example. The Apache Cassandra plugin, last updated March 27th, 2017. Only 3 releases. None of these releases have full release notes on them. This is before we really developed kind of solid engineering practices for how we do release management in aka.net. Those are the things you want to take a look at, is the frequency with which code is updated and the number of people who are submitting code, submitting issues, and whether or not they're being answered. Another metric I like to look at is I go to the issues list and I take a look at all the issues here, how new they are, and I look at the basic number of comments that are done next to each of these. So this kind of tells me if there's triage and kind of active discussion going on here. So looks to me like we're doing a pretty good job on the Akka.NET project so far. We have some issues here that members of our team have logged that no one's responded to, but that's okay. That's kind of on our internal work queue somewhere. I can also take a look. If I click in here, I can see some milestones that we have for a couple different releases. I can see all of our previous milestones here. So this kind of gives me a sense of what the roadmap looks like. I can also take a look at our releases. And I can see that our most recent release was 13 days ago. And then we had another release about a month before that. Another release about a month before that. Another release a couple of weeks after that. So it looks like there's a pretty decent release cadence going on there. Those are all pretty good signs. The other things I like to take a look at is the source control. So if I take a look here, let's see, I don't know why this pull request is failing. But if I take a look here, I can go ahead and see that we're using Azure DevOps. I can go ahead and look into the logs if I want to and get some information out of it. And so the fact that we're using CI, the fact that we have multiple contributors, the fact that we have recent releases, and the fact that we have, let's say, just a basic, we're relatively responsive on issues, those are all good signs. Actually, let me give you another example real fast. If I go to Azure.net, here's something you don't want to see. If you go ahead and scroll down here and you say, this project stopped updated, this project stopped developing, let's see, when will the next official version be released? Stop developing, let's see. There might be some older ones of those if I go further back in time, but you get the idea. You don't want to see, is this project dead issues showing up? That's usually not a sign that no one's really doing any active triage on there. Okay, well, Paul, thanks for your question. Let's see, do we have any more questions before we sign off for the evening here?
So I don't see anything currently. I'll give folks a couple minutes to chime in if there's anything that anyone's been waiting to ask. In the meantime, I was actually just going to build on Paul's question and kind of extend that to the commercial side of things for Akka.NET and Petabridge specifically, where I think there's obviously the one side that you showed of showing being able to look at the insights and get a sense of the truck factor and that sort of thing. But there's also this implied, part of the truck factor is also Petabridge's sustainability, right? Where some of that is seeded, being able to have a model that can afford to pay developers to work on this full time. So I'd be interested to know how, if you were kind of coming in and taking a dependency on a commercially supported open sub OSS project, what are the sorts of things that you would look for to try and judge sustainability, and realizing that's a little bit of chicken and egg, because obviously
right,
they need customers in order to be able to sustain, but it kind of works both ways, right?
So you want to look at how direct the line is from the project to the revenue the company makes, because that's going to be your strongest indicator of how healthy the project is. So I'll give you a good example. So with Akka.NET and Petabridge, if you go to our website, I mean, most of our sort of stuff on there is all about selling support plans and training for Akka.NET. So the line is pretty clear that the better Akka.NET does, the better Petabridge does. Let's take a less obvious example. Let's talk about something like Google and Kubernetes, for instance, right? So Kubernetes, originally a Google project, is part of the Cloud Native Computing Foundation now, I think. And Kubernetes is a really complex project that is super successful, and it is very complicated. It's a much more complicated project than Akka.NET is. But there's a direct line between Kubernetes success and Google success, because Google offers hosted Kubernetes services directly. And the more successful Kubernetes is, they have an instant platform they can use to get people to lift and shift from one cloud to another to adopt to theirs. So there's a direct line between their cloud business and Kubernetes. And the fact that Kubernetes also has multiple commercial vendors behind it. Let's say you've got Rancher Labs, OpenShift, which is now part of Red Hat and IBM. And I'd probably say maybe 24 of them. That's a really healthy open source project, because there's so much skin in the game, right? And the revenue that gets derived from revenue that gets derived from Kubernetes directly affects the bottom line of all those companies. So no one's going to let it fail. A project that is actually probably riskier would be something like, if I took a look at, let's say, the Dapper project for Microsoft. Dapper is their kind of distributed microservices framework. And it's very exciting. Mark Russinovich is kind of the guy who's the driving force behind it, et cetera. Dapper is meant to be an indirect play at generating revenue. It's designed to basically win some thought leadership because it's all built around Kubernetes. And Microsoft is not the only game in town with Kubernetes. Everyone's got Kubernetes as a service. So all of the investment that's being put into Dapper is being built on the premise that this will get people who are really serious about microservices and being able to develop those microservices in multiple languages to maybe take a look at Azure. Well, if Dapper gets really expensive to maintain and someone who controls product marketing budget inside Microsoft says, hey, I'm not really seeing a connection between all this time and money we're spending working on that and increased Azure Kubernetes service revenue. I'm not seeing a correlation between those two. That's how that project can end up getting its ox gored, so to speak, is that the relationship between the open source being produced and the business that supports it isn't as direct. So that's something worth looking at from a sustainability point of view is, do I think this technology could be killed by a reorg or someone with a budget and a vendetta inside that organization? And if the answer to that question is maybe, then you've got some risk there. Let's see.
So yeah, it looks like we were able to cover every question that folks had. But really want to thank you again, Aaron, for taking the time, especially knowing that you're a couple hours ahead of us in terms of time zone, especially. Really appreciate you taking the time to run through all this. That was a lot of awesome content. Okay. And I think we might have lost Aaron in the process, but we were kind of just closing up anyway. So thanks again, everyone, for sticking around and hanging out. We'll have the recording of this up on our YouTube channel within the next day or two. I'll send the link out everywhere once that's done. Hope to see you in a couple weeks, and in the meantime, stay safe and healthy, and we'll see you soon. Have a great night, folks.